Here I would like to explain my model that I built for predict claim insurance. Actually, here use a neural network algorithm for predict. There are many ways for making some prediction, like using SVM, naive Bayes, and etc. Why I use neural network? Because neural network is better for a big data, and this claim insurance have uh, so many feature of the data, and neural network has good architecture for build the best accuracy. So at a time when I use Google Auto ML tables, they use neural network too for training their models. You can check in this link. Yeah, Google Auto ML using feed-forward deep neural network. It's one kind of neural network too that have many layers there. So it's called deep neural network. But in here, I just make four neural network. Actually, that's depend on the layer. After you see the data, you can conclude this claim insurance is a multi-class classification. You have many input and many output. And the data combined between numerical data and categorical data. In Google Auto ML tutorial, there are classification divided into three: binary classification, multi-class classification, and regression. And here we are in a multi-class classification. Multi-class classification is for model predict one class from three or more discrete classes, something like that. Okay, so take a look. What we need here, I'm making some code using Python, and then I use pandas for data manipulation. I use scikit-learn for doing machine learning process. I use NumPy for doing mathematical process, and matplotlib for visualization, and Keras for doing the deep learning process based on TensorFlow. And what's the goal? The goal is actually for predict the claim data insurance based on this, the data. The target is we want to predict that based on claim injury type. So the neural network will build a classification model which will predict the target from classes in the selected column. So the result is non-com, made only, time total, and etc. How is the workflow? Basically, this tutorial same with AutoML tables that use standard machine learning workflow. First, gather the data, and then we have to prepare the data, and then we train the model, and then we evaluate it, and we test and predict the model. Okay? Number one is gather the data. Here, I already upload the CSV dataset in the Google Drive, so I just gather the data from there and display the data using pandas. Usually, if the data has a big size, we just upload the zip format and doing unzip here. And basically, you can use some Linux command in Google Collaboratory. Start with this. Then, just write the command. Example like this. So, here, original dataset. This is the original dataset that has not been modified. This is the original data from Kaggle. The first, you have to mounting the drive. You have to mounting the drive in order Google Drive can check, can upload, can what's it? can tweak with the folder in your Google Drive, something like that. And after that, we have to import the Python library like pandas, numpy, seaborn, matplotlib, os. Pandas is for uh, doing machine learning, and numpy for mathematical process, seaborn and matplotlib for visualization, and import os for this. It's like you go to another dictionary in Linux in console, like that. After we import, we change the directory for unzip the dataset, like this. Claim ny is the name of folder that I use here. Yeah. So we have to unzip using this command, and then we're doing ls for known what's inside in the dataset. Here, the dataset, and then we open the dataset using this code. Read dataset. Pandas have some function for read dataset automatically. Tara, after you run, you will get the first 10 dataset. You can use some code here, data point help 10. You can see the data here, all the data. Okay, and after that, you can check the rows in the data around 3 million. And you can check the information of the data, whether the color, whether the data type. You can see here the data type. And after we know the data from original dataset, we take a look in the dataset from 2014. Here, the dataset that will training. Okay, the dataset that we will process is count for 2014 till present. This based on the feature of the accident date, 2014 until now. So I trim the data from 2014 until now, and we get this. Take a look in yes, this. And after we have the data from 2014, we check the row of the dataset around only 1 million. Okay. And after that, after we have um, the data from 2014, we continue in prepare data. Understanding your training data is important to preventing data leakage and training serving skew. So, before using any data, make sure you know what the data means and whether or not you should use it as a feature. And then, after that, we check the correlation. High correlation should be flagged for review. And after that, we clean up the missing data, incomplete and inconsistent data. And after that, we training. Make sure you only provide input feature to the model that are available in the exact same forest serving time. This will influence the accuracy. Okay. Okay. Take a look. First, we check the data type first. Maybe you can see I always check the data type for make sure that it's good or this is the, the best way of the data type. And then after that we check the detailed data. We need to understand the columns and the type of data associated with each column. So first check the data type. If all features are numerical and do not have any categorical data, we don't need the data conversion. But if all features all column have numerical and categorical data, we need conversion for the categorical data. And this is where we have to do. And second, after we check the data type, we check the correlation. We plot with a heat map by using the correlation of the dataset. This will help us to eliminate any feature of any column that may not help with the prediction. Okay. And the third, after we know the best feature that associated with the target, we just eliminate the data. Eliminate any feature that may not help with the prediction. Okay. Okay. So here I will check the data type first. Check there are categorical and numerical data. With describe here you can see noun, numeric, categorical, date, text. There are so many data type here. So we have to make we have to check the correlation. We have to check the correlation of all data in heap map. Only numerical data that will visualize. So we need to making some conversion of categorical data and eliminate some future that we don't need it. You can see here. Okay. The best correlation is actually 1, but in minus, in negative, it's not good for the correlation. So after we check the data, we should eliminate data that we don't need it, like the date, zip code, gender, the description. Actually, that's not suitable that we want to predict. That's not so associate with the target. After that, we check again using the info. We check the data type. And after we check the detailed data, we have continue check the missing value. There are none here. Yes, none. It's a missing value. Video. So we have to take a look using this. We know that date and first hearing date is null. And after that, we make some conversion from categorical to numerical. For handle categorical data, there are several techniques. First, replacing value, encoding label, one-hot encoding, binary encoding, backward different encoding, and miscellaneous future. I take some reference here so you can check this link. So, in this research, in this code, I will use two conversion method. First, replacing value. I use this for handling X. And encoding label, I use this for handling Y. Okay, so because later we will split the data into X train and Y train. Okay, the first using replacing value. We just replacing the category with the desired number or label. Example this. So we change the PVD NSL become 5, mate only become 2, cancel become 0, something like that. So if the result of prediction is 2, it's mean mate only. Step by step for replacing value, check the unique from the column. We call column is a feature, okay? Unique, it's mean a column with string or character that you want to find the number of unique elements present in the column. Pandas library in Python easily let you find the unique value. And then making the label based on the future using a label encoder for the target. And for X, we use a replacing. Here, you can see here. I use a label encoder for Y data. So I use here, I will transform it. So you have label here. Here. I will encode the claim injury type PBDNSL become 5. I will encode made only become 2. So here I took the label here. So in the result, if the result of the predict has a cancel, so the label have 0. Okay. Okay. And after that, we take the label. We check the label. We check the label here. After replacing value, we have to clean the data. Clean for symbol, clean for punctuation, like that. We know here, we can check here by using a unique code for this body code. There are many symbol and punctuation here. You can see here. We have to clean it because it will influence the feature that associated with the target, like that. With cleaning and data, you can see the code already flowed. The code already in float data type, not object. So we can check the correlation based on the label here. You can see we check the correlation. I mean, we check the what factor that associated with the target. You can see here label, yeah, that's one, and then close count, hearing count, average weekly wage, and we can check here close count have a big associate, have yeah, big associate with the label. So the close count cannot be eliminated. Okay, cannot be eliminated. I mean, so the close count cannot be eliminated because this is uh, something feature that have influence, that have big influence with this target, with the label target. And then we check the unique again, yeah, ta-da, and then after that we change the label. Yeah, this is just only the cleaning, same with the first. And after we cleaning, we prepare the training data. I check the data type again for make sure, and then I check the correlation again for make sure again. We know that here. Okay, take a look in this correlation. Close count have a big associate with this label because this almost one, and we check the claim type and claim identifier has a negative, so that's not have associate, that not have associate with this label. So we just drop the feature that have no correlations, like claim identifier. We have to eliminate this claim identifier. We have to eliminate the accident, current claim status, something like that. So we have to eliminate all the negative value of this correlation. Okay, and then I'll check again. Okay, I will export the training data into CSV, just using this to CSV. It's good, right? And after that, we drop this because this data that will split. Okay, after we prepare the training data, we have to handle missing value in training data. In above, I already say that the data have a numerical and categorical column, so we have to uh, handling this missing value. Okay, so the numerical I will replace with 0. We check again. This is the code that for replace this, replace the missing value, replace with 0. After we replace with 0, we take a look again here. Okay, that feature that we will build, we will associate with the label, we have a good feature with the label is already clean. Okay, we check here. Yeah, no nan here. And after that, we make some x and y. X contain with all feature that have correlation with the label. Okay, and y is the label. So let me check here. So this is the future that we will build, that we will build in the model. So almost in here except label and claim injury type will enter the X, okay, and the Y we use the label like that. Okay, after that we split the data set. Okay, that this data set I use 70% for data training and 15% for validation data and 15% for data testing. Okay, we can split using scikit-learn here, and after that we can check with the shape code here: xtrain, xfail, xtest, xtrain, xvalidation, y, yeah, ytest, like that. After we split the dataset, we have to standardize the input. Since our input features are not at the different scales, we need to standardize the input using min-max scalar. You can check here. I took some reference for how to normalization and standardization data using scikit-learn. Here I use a min-max scalar. Here I use min-max scalar and take a look here. This is the result of min-max scalar. Scalar is around 0 until 1. Okay. After that, we can check here. We can transform in xtest. We can transform in x4 like that. And here, I use label encoder again for y variable, y train, y test, y fork. This is have some what's it? This can be encoded from the label, fr from the numerical label being a categorical like that. And after that we check the X-train shape. This is 17, Y test shape for 8, and this is the Y test. Okay, after we standardize the input, we have the best data set that we already split between 3: testing, training, and validation. We will continue build the neural model. What's the neural network? Okay, neural network, you can see the video here and this article. I took some video here for make sure that this is the best for understanding for the people. Maybe here, this is the architecture. You can see in this video, this is in a good way for knowing the neural network. So, neural network actually have a 3 layer: input layer, hidden layer, and output layer. And input layer, it's for future var, future to, future tidak associated with the target. So this is why we have to know the correlation. We have to know what is the best future or what is the best column that have a good associate with the target. Okay, and after that we have a hidden layer. We have a hidden layer. This is for yeah. This is what's it? This is the point of the neural network. And after that we have output layer. Okay, so here for this example, okay, uh, I use example for image. Okay, image classification will be used to show a more descriptive explanation on how a neural network makes prediction. A neural network can start by taking a picture or a face by breaking it down into certain features and rebuild it by telling the next layer if the features are there. By the end, depending on how many one or two features has space on, the neural network can make a prediction by telling how many features it saw compared to how many features make a face. If most features are seen, then it will classify it as a face. Okay? Otherwise, it will be classified as not face. So, actually, image and all the data have a same characteristic. So just take this, the future, and enter the hidden layer, and the hidden layer have want to what's it training based on the hidden layer, and the hidden layer will have a result in output layer. So for improving the neuron, we have activation function. For better understanding, you can check this video, it's good to you. So what we'll do here, we already pre-processed the data and we are now ready to build the model using neural network. We use Keras, it's based on TensorFlow, to build the neural network. Keras has a function to create neural network layer. The Keras library that we use is a sequential to build the neural network, and the dance to build input, hidden layer, and output layer of a neural network. So here we have, this is my architecture of my model. Input, we have 17 input feature. Based on trained data set, there are 17 column or 17 feature. Okay. And output, we will have 8 output that we want to predict. And I use for hidden layer. First, hidden layer use activation function ReLU and 64 nodes, and the second same using ReLU and 64 nodes, and the third I use same ReLU and 64 nodes, and the fourth I use ReLU and 32 nodes, and for output layer I use softmax. Yeah, every neural network architecture this only 3 this. Maybe the difference is only in the hidden layer, only in the activation function, and only in the nodes, like that. So take a look in the neural network. The first, because I use Keras based on TensorFlow, we want to import the library first here. And after that, here the model. Here the model. The model I use sequential. The first hidden layer, as I said, have 64 nodes, and then this is the input. The input is uh, 17, and I use activation function is rail. And the second hidden layer, I use dance and use 64 activation value. And then the third, I use 64 nodes and activation value again. And the fourth hidden layer, I use 32 and activation value again. And for the output, you can check here. I use dance, and then this is 8, and the activation is softmax. So the model, the model, we will compile this. All here, we will compile this. I use some categorical course entropy, and then I use optimizer Adam, and I use matrix. This is just for accuracy. And tada, this the time for training. Here I will train the model in 10 epochs. Okay, epoch it's like what's it? Um, yeah, here I use 10 epochs, so the training only use 1 until 10 epoch. So if you take a look in epoch 100, and the epoch will 1 until 102. Okay, so after I training has the accuracy here, so I will evaluate. You can check here using a metric. You can know uh, how many loss, how many categorical accuracy, how many validation loss, how many validation categorical accuracy, something like that. So here I make some mean, and for evaluate here the accuracy is 83.42 and the loss value is 0.41. Okay, the accuracy actually based on many ways, like uh, the hidden layer, and then how many layer in the neural network, and then how many epoch, how many epoch, yeah, and then the data, and there's so many factors that influence the accuracy. So after we know the model, after we build the model, and then after we know the accuracy, we make some prediction here. We make list uh, the label 1 cancel, 2 non-count. This is the category of claim injury type. So we can check here. So here, for predict, I use this data. I mean, this is just for check the predict it's true or false, like here. Okay, so I will check this predict based on the order data. For example, here I use data on array 9 here. So the result should be non-count, non-compensation, and the label is 1. So after we training, we can predict it like that. We use predict classes for predict the data based on the model. We have 1 here, and it should be 2 non-count. So it's true. Okay, the prediction is true. Okay, so yeah, that's the prediction. If we want to deploy in in another code, we have to save the model. Here I will save the model, the scalar, and the prediction class. It's good for if you want to have if you want to try another architecture that you do not have the training again. Okay, because training is need a lot of time. If you want, if you have some approach another 100, and if need a lot of time, so training is need a lot of time. So here I will save the scalar, I will save the model, I will save the prediction class, and then I will load the model and scalar, I will load the prediction class. Okay, so if you want to make different model and maybe 5 model, it's okay. you can load here. Okay, maybe you will compare with the accuracy. It's okay. So after we save the model, we know the model. So this is, I make some code for deployment. Maybe this is good for you if you want to deploy in another code using Flash or using Django, something like that. Here, here. For example, if we have some JSON or dictionary data below, you can change the data and make the prediction like that. You can change here. You can change. You can change here. Maybe okay, hearing count 0 and close count 1, and average weekly wage is 23, and part of the code is 45, and the gender is male, and you can run here. So this is for prediction result. So the prediction is for temporary, like that. Okay, that's my explanation. I hope you will understand what I do. Actually, this code same with what it Google AutoML doing actually. You can see in Google AutoML here, there are import, train, models, evaluate, and test and use. Import, we import the data, same as I do, and we train the data, same as I do, and we make some model, same with I do, and we have to evaluate, and we test and use in predict. That is same with I did, but if we use some here, use Python and using pandas, numpy, and keras, we can make sure that one by one variable, we can make sure that what algorithm that we want to use. But in here, in Google AutoML, we don't know what the algorithm that they use. We don't know what's it, what make their the best accuracy. So that's all for me. I hope you will understand my explanation. Thank you very much.